If you saw my show on 6G, you already heard me say this. 6G will be faster than 5G, and that's the least useful thing you can say about it. In this video, I want to show you why that sentence matters and what it hides. If you've been in telecom for a while, you've seen this movie. Every generation gets reduced to one headline number, and that is peak downlink speed. For 4G, that kind of made sense. It really was mobile broadband. 5G started to break that model with ultra-reliable low latency and massive IoT, but we still talked about it like faster 4G. If we do the same thing with 6G, we will completely miss what it's actually being built to do. Look at the early 6G roadmaps and white papers and you'll see three themes repeating: terabit per second peak rates, sub-millisecond end-to-end latency in specific scenarios, and a tight integration of communication, sensing, and compute in one fabric. Those numbers are impressive, but they're not the interesting part. The interesting part is what those capabilities are being designed to carry. 6G isn't being built for smoother Netflix, but for workloads where the network drop for a second is not annoying, it's a system failure. So instead of asking how fast will 6G be, I want you to look at it through three lenses. First is deterministic latency, and not just fast on average, but bounded predictable timing. Second is AI native RAN, where intelligence is part of the architecture, not a bolt-on script. Third is integrated sensing, where the radio doesn't just connect, it actually perceives the environment. Those three together explain why 6G is just faster, 5G is such a harmful simplification. 5G can already hit very low latency in the RAN in lab conditions with tens of microseconds in some optimized profiles. The problem isn't the best latency. The problem is the worst case latency, the ugly outliers. Deterministic latency means we don't just say it's usually fast. We can put a hard bound on how bad it can get and design safety around that. In the IMT 2030 vision, 6G extends ultra-reliable low-latency communication into full industrial automation, remote multisensory telepresence, and ultra-precise control systems. In those environments, one random 120 millisecond spike in a system that usually responds in 2 milliseconds is not a statistic, it's an incident report. Imagine a factory safety system that stops a machine when a human crosses a virtual line. On average, the network delivers that event in 2 milliseconds. On a once a day under congestion, it takes 80 or 100. On the dashboard, the average still looks amazing. On the shop floor, that one outlier is the only one people remember. So if this is what 6G timing is really about, why does almost every public conversation still sound like a speed race? There are three reasons the faster 5G myth refuses to die. They are marketing, measurement, and mental models. I'll come back to those in a few minutes. First, we need to finish the picture of what 6G is actually being asked to do. Today, we already use AI for the RAN in 5G to tune parameters, save energy, and predict traffic. 6G goes further, where it treats AI as part of the RAN's basic architecture, from how the air interface is controlled to how resources are allocated and services are orchestrated. In operator language, that looks like predictive mobility management, and not just reactive handovers. RAN-assisted deterministic QoS from radio through to transport, and AI co-running with baseband on shared accelerators at the edge cloud. The RAN stops being a dumb bit pipe. It becomes a decision-making node in the overall system. If 6G is going to support distributed AI, digital twins, and real-time control at the edge, the network itself has to help decide where inference runs, how traffic is steered, and which service intent gets honored when resources are tight. You can't do that reliably with a RAN that was never designed to host or coordinate AI in the first place. The third pillar is integrated sensing, sometimes called ISAC, meaning integrated sensing and communication. The basic idea is the same 6G radio waveform that carries data can also act like a radar. It can detect objects, estimate position, and build a live model of the environment as a side effect of communication. In a factory, that could mean the network itself notices a forklift entering a restricted zone. On a highway, it could help vehicles sense each other beyond line of sight. Indoors, it could give you centimeter level positioning for XR without needing GPS. None of that shows up in a speed test. You can't benchmark did the network detect the obstacle and act in time with a single megabyte number. And that's why calling 6G just faster 5G is not just incomplete, it's actively misleading. Okay, we've looked at what 6G is actually being designed to do. So why does the speed narrative refuse to die? First is marketing. 100 times faster is a simple story. Deterministic latency with AI native RAN and integrated sensing is not. It's easier to sell a big number than a new mental model. Second is measurement. We know how to measure throughput. We're still figuring out how to package reliability, determinism, and sensing accuracy into numbers that fit in a keynote slide. Third is mental models. For decades, we've trained ourselves and our customers to think of networks as faster pipes. 6G is closer to an intelligent, sensing, distributed control plane. That's a very different picture, and those shifts always lag the technology. So the next time you hear 6G is just faster 5G, translate it, ask what are they doing about deterministic latency, where is AI actually living in the RAN, and what role does sensing play in the architecture. On this channel, I'm not here to hype the next G. I'm here to unpack the architecture behind the slideware from 5G to 5G Advanced to 6G. If you want more deep dives like this, subscribe to Techtonic and watch the AI RAN architecture video next. It's the other half of this story.